and welcome to Trigonometry in 3D. Just before we start, a reminder that there is a notes jotter available for this video. Just check the description link below for a download link and you can work along with me as we go through the video. Okay, so in this question we've been asked to find the angle x, and we're dealing with a cuboid here, so we're dealing with lots of right angled triangles involved, and just trying to work out using trigonometry, our basic SOHCAHTOA, how to find the different lengths. So within this one you've already got marked some very important features. We have AE and we have AF, because those two are the two lines forming the angle we're looking for. And if we just drop down a further line, we have a right angle triangle. So eventually we're going to need to use the right angle triangle EFA, because we're trying to find the value of x. Now, in order to do that, we're going to need two pieces of information. We need two lengths in order to find an angle. Do we know any of the lengths currently? Well, we can see that FE is the height of the cuboid, and so it must be the same as this height here. So FE must be 6 centimeters. But unfortunately, we don't know the length of AF or the length of AE, and therefore we're going to have to do a little bit of work in order to find them. And so we have to ask ourselves, what's going to be the easiest way of going about that? Well, the easiest way is going to be if we actually try and find AE, because what we do have here is a right angled triangle at the bottom of the shape. I have a right angled triangle going from A to D to E, and DE I know is 3 and AD I know is 9. And I need to find the length of AE, and therefore this one is a case of a question where we have a right angle triangle, we know two sides and we want to find the third. We're going to need to use Pythagoras, and so a squared plus b squared equals c squared. A is 3 and b is 9, and so 3 squared plus 9 squared is c squared. 3 squared is 9, 9 squared is 81, so let's put that together. We get 90 is c squared, and so c is the square root of 90. I'm going to leave it as that just for the time being, because it's just going to make it a little bit easier when we actually come to typing things into our calculator, because the root of 90 is going to be an irrational number, a very long decimal. And so I've just worked out that A to E is root 90. Let's use that in the blue triangle. So in this one we have a right angle triangle and we're trying to find an angle. Now if we ever see a right angle triangle and we have an angle involved, that means we're going to need to use trigonometry, we're going to need to use SOHCAHTOA. And so what we need first is to label the diagram. Opposite the right angle is the hypotenuse, opposite the angle is the opposite, and the other one is the adjacent. And then we need to think about SOHCAHTOA. Which one am I going to be using? Sine, cos or tan? Well, in this case I have the opposite and I have the adjacent, and therefore I need to be using tan. So tan x equals opposite, which is 6, over the adjacent, which is root 90. But because in this case we're finding an angle, we must remember that we need to use our inverse here. So x equals tan inverse of 6 over root 90, and that requires a calculator. So we're just going to grab the calculator, shift tan of 6 over root 90 and close our bracket, and we get that x is 32.31 degrees. So in our next question we have a triangular prism, and we are told that M is the midpoint of AB, angle CEM is 40 degrees, and we are needing to calculate the length CM. And so with this again, what we need to do is we need to create some right angled triangles that we can use in order to answer the question. So the first thing I'll be adding in here is angle CEM. CEM takes us from C to E and then from E to M. And so we definitely have a right angled triangle here that is going to be needed, and that is going to be the triangle CEM. And we've been told that CEM is 40 degrees, so what we've been told is that that piece of the diagram is 40 degrees. But in this diagram we don't actually have any lengths at all. The one that we want to find, CM, is here. So we need to know that value, and so we're going to need to know either CE or EM. And so it goes back to the original diagram to decide once again which one's actually going to be the easiest one for us to find. Well, given that CE is to do with the rectangle CDEB, there is not enough information on that rectangle for us to do that, and so our easiest option here is going to have to be, oh sorry, I just changed colour, from EMB. Now it may seem that again we don't actually have enough information about that, but let's just have a look carefully at what we've been told. So that is the triangle MBE. BE is 9 centimetres. Do we have any other lengths on that diagram? Well, the key here is that M is the midpoint of AB. AB is going to be the same as FE, 6 centimetres, and so the midpoint would mean that we're going to half that. MB is going to be 3 centimetres, and so from that we can work out ME, which is one of the other sides in our diagram. And so the first part is going to require a bit of Pythagoras again. We're going to have to work out what the hypotenuse is, and so we're going to have 3 squared plus 9 squared equals c squared, and that's 9 plus 81, so that is 90. C squared equals 90, and so c is root 90. So it's the same values again, actually. C equals root 90. And again, I'm going to leave that exactly as it is, just because it makes things a little bit easier when typing it into the calculator. I want to find out CM, so I'm going to call that X. And I'm going to now have a look at my right angled triangle CEM. And in this question, the key here is that here's our right angle. We need to label the diagram because we have an angle involved. So we have our hypotenuse, we have our opposite, we have our adjacent, and so again with SOHCAHTOA we just need to decide which one we're going to use. Well, we haven't got anything to do with hypotenuse, so it must be TOA, and so tan of 40 equals x over root 90, and therefore if I want to get x all on its own, I'm going to do tan 40 times root 90, and it should give me my answer straight away. So tan 40 multiplied by root 90 equals 7.96 centimetres. And let's just have a look at that. Does that seem sensible for the height of that shape? Well, it's got a 6 centimetre base, a 9 centimetre depth, 7.96, around 8 centimetres. Sounds very sensible indeed. Okay, so finally we come to finding the perpendicular height of a square-based pyramid, and in this case we've been told what the angle is between the side EC and the base of the shape, the pyramid, and so in this case we need to think carefully about what this actually means, the perpendicular height. If we are dealing with the perpendicular height of a shape, then that means a line coming straight down from the very top of the diagram, the very top vertex of the pyramid to the very centre of the pyramid. And so, once again, there's actually quite a nice clear triangle being formed. We have the triangle taking us from E to the middle of the diagram, so let's call it MC, and we've been told that this angle is 50 degrees and EM is the length that we want to find out. Now again, if we want to do that, we would need one more piece of information. We would either need the hypotenuse, the length of EC, or the length of MC. Which one is going to be easiest to find? Well, let's think about what's already marked on the diagram. We have a square-based pyramid, and therefore we have a right-angled triangle. And that right-angled triangle is 4 centimetres by 4 centimetres. And this is A, B, C. And we need to find out AC to begin with, and so we're going to need, once again, Pythagoras' theorem. We're going to have 4 squared plus 4 squared equals C squared. That's going to be 16 plus 16, which is 32, equals C squared. And so C is going to be the square root of 32. Square root of 32, if we just do type that one into the calculator, square root of 32, we get 4 root 2. Okay, so let's leave it again in third form, 4 root 2 for the time being. And the reason I'm doing that is that AC goes all the way from one corner to the other. But in the diagram we're using, we're only using half of that. And therefore MC is going to be half of this value. What is half of 4 root 2? Well, that is 2 root 2. And so now, with that information, we have enough on our diagram in order to find EM. We're going to need to, as always, label our diagram. So there's our right angle, there is our hypotenuse, the opposite is over here, and the adjacent is here. We don't have anything to do with the hypotenuse, and so we are using tan again. We are using tan of 50 equals the opposite, which is what we don't know, so let's call it EM, over 2 root 2, and therefore to get the perpendicular height EM, well, that is going to be tan 50 times 2 root 2. And so let's just type that into our calculator. Tan 50 times 2 root 2, and it equals 3.37 to 2 decimal places. And again, having a look at those values, does that seem sensible? Well, given that the base was a 4 centimetre base, a 3.37 centimetre height does sound very sensible indeed. And finally we come to the exam question, which came from the Edexcel paper in June 2018, and it was on higher paper 2. And we've been given a cuboid this time, where AB is 7.3 centimetres, CH is 8.1 centimetres, and angle BCA is 48 degrees. We are asked to find the size of the angle between AH and the plane ABD, and give our answer correct to 1 decimal place. So the first thing I'm going to do here is I'm going to mark on the information I've been given. So AB is 7.3 centimetres. So that means that these lengths here are all 7.3. That CH is 8.1. So CH is the height. So no matter what, all of the heights are going to be 8.1. And angle BCA is 48 degrees. And so what I'm going to do here is I'm going to mark that as an angle. So BCA goes from B to C to A, and so that is the angle that we're dealing with as being 48 degrees. Now, eventually we want to find the angle between AH and the plane ABCD. I should just mention what this means. The plane is the flat face which is made from the letters A, B, C, D, and so what we're actually looking for is the angle between the line AH and the base, so basically with AC. And so eventually what I'm going to be looking for is the right angle triangle that I've drawn in blue. I'm going to be looking for a height of 8.1, and we are looking for the angle X. So this is ACH, and so the angle is what we're eventually looking for. Now, if I'm going to find the angle, I'm going to have to know either the length AH or the length AC. Now, given what we already have marked on our diagram, this length AC would appear to be a good one to use, because we can form a right angle triangle. In this case, B is the right angle and A and C, and we know that AB is 7.3 centimetres, and we know that the angle at C is 48 degrees. And so if I need, as it says here, I need to find AC, well, I can use this diagram to do it. So this is the length that I want to know. Let's label up the diagram. So I have my angle. Opposite the right angle is the hypotenuse. Opposite the angle is opposite, and adjacent is here. Now, I don't want anything to do with adjacent. I already know the opposite and I want to find the hypotenuse, and so I'm going to be using SO from SOHCAHTOA, and so sine 48 equals opposite 7.3 over the hypotenuse. And so to find the hypotenuse, quick switch, multiply by the height, divide by sine 48. So H is 7.3 over sine 48. And so H, the hypotenuse in this case, is, let's grab the calculator, 7.3 divided by sine 48. That is 9.823. I'm going to put a little dot 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 because it does go on for a little bit longer, but that is going to be used in this diagram. So 9.823. I need to find X, so I now need to go through trigonometry again. I need to go through SOHCAHTOA. There is my hypotenuse, there is my opposite, and there is my adjacent. I'm not interested in the hypotenuse in this case, and so I'm just going to use TOA for TOA, and that tells me that tan X equals my opposite, 8.1, over my adjacent, 9.823. And remember, because it's an angle that we're trying to find, we need to use the inverse. So tan inverse of 8.1 over 9.823. And finally, type that into the calculator. So shift tan of 8.1 over, and I'm going to use the answer button so that I get the full version of what I've just worked out. Close my bracket, and I get 39.51. So 39.51. Let's just check. Yep. And go back to the question just to make sure my accuracy is correct. Well, my accuracy was actually correct to 1 decimal place, and so I just need to change my answer here. It doesn't have the 1 at the end. It is just 39.5 degrees.